Hello, my name is Narcis and I am the leader of the Full Body Interaction Lab at Pompeu Fabra University. Since 2015, we have been developing this intelligent handheld flashlight comprised of an embedded projector, an inside-out tracking system, and a computing element to generate the projected stimuli. We call it the AR Magic Lantern. It is a spatial AR system, meaning it projects the augmented visuals onto the physical reality. We have been collaborating with the Museum of the History of Barcelona, specifically in the past few years on the remains of Barquino, the ancient Roman city of Barcelona from 2000 years ago. The trigger for starting the design and development of the ARML was the reluctance of many heritage sites curators toward common AR technologies. They believe they isolate visitors, breaking group dynamics, that they hinder spatial awareness of the heritage space, and that they entail real dangers. We decided to base the solution on SAR because of its potential to open the experience to a group of people through the projection. Because of this, we believe we can counter the issues of other AR technologies, and we want to make AR feasible for heritage site curators. We decided to compare the ARML that provides a natural flashlight metaphor with an AR pass-through system such as the MetaQuest 3. Our research questions in this case were defined around analyzing usability and satisfaction, presence and awareness of physical space, social aspects, and the inclusion of other companion visitors. Therefore, we defined a between-subject study with a condition for the Quest 3 and another for the ARML. The context of the study was a cultural heritage experience that takes advantage of an in vivo setting in a real heritage site and with real visitors. We therefore designed an experience that worked well for both conditions to keep the comparison fair. The experience focuses on a part of the heritage site that was an ancient business to make a fish paste, very much appreciated by ancient Romans, called garum. Here you may see alternately sequences of the quest and the ARML experience. The boss of the business guides the users, who act as apprentices and learn to find and use the ingredients to make garum. We had two main hypotheses. The first one was that defining two conditions and using the same AR experience, we would observe different user awareness of the physical space. And this would be measured through a number of dimensions: performance, efficiency, presence, and user satisfaction. The second hypothesis was that, again, given the two conditions with the same AR experience, we would observe different effects on the companions of the user having the experience. This would be evaluated through notes taken by our research team. We defined the experimental setup at the heritage site by recruiting real adult visitors in a voluntary manner, providing an informed consent to agree to participate, and the first short anonymous demographic questionnaire. Then we randomly assigned them to perform either the Quest Garum experience or the ARML Garum experience. Finally, a post-test questionnaire was administered to obtain information on their subjective perception. Therefore, we gathered data through two main types of tools: the participant reports that captured the perception of users through questionnaires and notes taken by researchers, and the system data that was logged onto files in the device. Here we can see the questions, most of which were based on Likert scale, and the variables we used from the system logged data. Regarding the satisfaction of users, all feedback was high and there were no significant differences between devices. Similarly, there were no differences in recall or task completion, having achieved excellent results for both devices. These, together with satisfaction, were good results to eliminate any doubts on whether any of the two devices were causing difficulties or discomfort on the users. Regarding the time spent by users and their efficiency, we saw a significantly larger time spent by ARML users than those using Quest. We will go into this fact in the discussion. We also recorded usage patterns and noticed that both conditions had the same results regarding sequence of tasks and asking for help to the boss. However, the range of physical space explored by users showed a huge difference between conditions. ARML users explored a much larger area of physical space compared to Quest users. We also analyzed whether there was a time perception bias. Users in both conditions underestimated the time they spent in the experience, again showing that there were no negative issues in their experiences. Finally, our notion of presence, based on whether users felt more present in the real or virtual world, did provide significant differences. ARML users showed a greater presence in the physical world, while Quest users showed a greater focus on the virtual world. Given these results, we can see that the Quest users were more goal-oriented and spent less time in the experience, but also explored less physical space. This suggests that they took a competitive role much like a gamer. Unfortunately, this works against the situatedness of the AR experience because it means that they focus more on the virtual elements alone. On the other hand, the ARML users were less goal-oriented and spent more time exploring in the experience, but explored more physical space. This suggests that ARML users showed a free-roaming attitude. Now, AR experiences must provide engaging experiences without distracting the visitors from the actual physical context. Our results seem to suggest that neither device actually hindered the purpose. However, ARML users showed a greater presence in the physical environment compared to Quest users. This suggests that the ARML users had a greater awareness of the physical space. We also observed that Quest users were left aside by their party companions because although users could see the companions could not see the experience. On the other hand, ARML users kept the group dynamics as they could openly share the experience with their companions and even other visitors. Summing up, our first hypothesis is confirmed, showing a difference in the two AR technologies regarding the awareness of the physical space. We have seen that the ARML provides greater awareness of physical space through, on the one hand, a greater potential of exploration of the physical world and a greater feeling of presence in the physical world. This clearly satisfies the curators and puts them in a better position to accept AR experiences for their sites. On the other hand, our second hypothesis is also verified as we have seen differences in the experience of the users with or without the companion visitors. This also places the ARML at an advantage because it manages to maintain the group dynamics of small parties of visitors that visit the site together, which is actually a very common way of visiting such spaces. Hence, this also satisfies curators. Therefore, the main takeaways from our study are that we have compared two AR technologies in a real setting with real users, comparing for the first time pass-through headset AR and a real handheld SAR device. We have observed high usability, engagement, learning, and satisfaction in both. However, the ARML provided visitors with greater awareness of the physical space of the heritage site and its structure, while we observed an isolating effect on users of the Quest 3 with their companions and other museum visitors. Finally, we can say that the ARML fosters group dynamics, which is good for public spaces in general. Now, it is important to note that this does not mean that SAR, or the ARML, is better in general compared to Passthrough AR, or the Quest 3. Rather, we know now which one to choose for each context and application. Our future work is based on the fact that this is an ongoing research. We are studying how the experiences of the ARML differ from other AR technologies, and we are in the process of understanding how to best use each AR technology. And we are starting to explore new applications of the ARML in other fields such as health and learning. We are happy to share with all of you that we have made the ARML accessible as an open source platform under MIT license, including the basic hardware configuration, the 3D printable case, and the SDK for developing from within Unity. These are our references. Thank you very much for your attention.